Hi, following is a project to predict home prices based on available features in a given dataset. The dataset I am using for this project is the Ames housing data which I derived from Kaggle.com. The aim of the project is to create different prediction models and compare them to find the most accurate among them. I have tackled this problem in Python by dividing it into two parts. Part 1 is data processing and feature engineering, and part 2 is modeling. As you can see, I have already imported the libraries in Python. We will begin by importing the data and looking at it. Based on the data documentation text and early observation of the dataset, we can see that there are 80 features, including sales price for the given dataset, and we have 1,460 values for each feature, including missing values. The given dataset has both numerical and categorical data, and we will be implementing feature engineering to provide an efficient way to fill the missing values and reduce the dimensionality of the dataset. So let's start. I realize that the ID feature is different for each entry and is more of an identifier. It is not going to help in any predictions, and thus I start by dropping the ID column. Next, we look more closely at sales price, which is the target variable. We start by finding its mean, standard deviation, skewness, and similar parameters. Now we will also plot a histogram to look at the data. As we can see, the sales price variable is not normalized. We will also check the skewness and the kurtosis for this sale price is positively right skewed. We will have to normalize it to be able to apply linear regression to it. This can be done by applying a simple log transformation. Now we will again plot it to check if the data was actually normalized. The plot confirms that we have a normalized sale price variable now. Now we move on to feature engineering. Studying the data documentation text in detail, we find that the data has 4 outliers which can be easily seen when we create a scatter plot between sale price and ground living area as suggested by the text. Based on the plot, we remove these 4 outliers to get a more accurate prediction model for our project. Moving on, we will now look at the missing values in the input data set. We start by creating a table displaying the features with the maximum missing values. We keep our threshold at 80% and plan to remove the features which have more than 80% missing values. As a result, we remove the 3 variables pool, quality, miscellaneous feature, and alley from our dataset. Now we will check if those columns have been dropped from our dataset.